Most AI programs fail for organizational reasons, not from technical ones. Teams say they want to move faster with AI, so they focus on models, use cases, and getting agents live quickly. But that's the wrong focus. Speed in agentic AI delivery doesn't come from pushing out more agents, it comes from changing where you apply control. Three shifts make the difference: shift left, shift up, and shift right. Used together, they let you deploy faster, around 50%, without compromising safety or stripping out governance. Let me explain how. Shift left is about prevention. In traditional software, testing and security sit at the end. That creates late surprises, rework, and delay. In agentic AI, late surprises are worse because agents don't just generate answers, they take actions. They're non deterministic by design. So, shift left in AI means making control decisions at design time by defining autonomy up front, embedding policy as code from day one, running evaluations continuously and not just at the end, defining explicit must not do constraints, and designing security and safety into the architecture. Prompts, specifications, and guardrails become first class artifacts, not afterthoughts. You constrain behavior before it ever runs. That compresses validation timelines. Instead of discovering defects in production, you prevent classes of failure from existing. The result is less rework, faster path to production, lower remediation costs, and fewer compliance surprises. But there is a limitation. Shift left reduces risk. It doesn't remove the bottleneck. Humans are still stuck in the middle. Shift up is about abstraction. If shift left moves risk earlier, shift up moves humans higher in the stack. In traditional delivery, humans sit in the middle. They write detailed designs, they code, they test, they fix. With Gen AI, that middle layer can be automated, where AI handles detailed design, code generation, unit tests, and low-level fixes. Humans move up a level. They focus on defining intent, setting boundaries, making architectural decisions, and approving releases. In other words, humans define the what and the guardrails, and AI executes the how. That changes roles. Architects decide the execution model. Is this a simple LLM call, a guided workflow, or a bounded autonomous agent? Engineers become supervisors of agent behavior, writing clear specifications, reviewing AI-generated output, managing trust levels, and approving higher-risk actions. This accelerates delivery in two ways. First, the manual coding bottleneck shrinks. Lead time drops because the slowest part is automated. And second, you can deploy in phases. You don't have to wait for perfect autonomy. You introduce trust tiers: observational, human approval, and bounded autonomy. Value starts flowing earlier, risk stays controlled. But there's a reality check. Even well-designed agents will behave unpredictably in the real world. That's agent drift, and that's where shift right matters. Shift right is about resilience, while shift left focuses on prevention. Shift right focuses on observability and operational safety. In traditional software, failure is obvious. The system crashes, an error is thrown. In AI systems, failure is often silent. An agent can produce plausible but wrong output. It can hallucinate. It can misinterpret intent without throwing an error. And nothing technically breaks. So shift right means building operational control around live agents. It requires execution tracing of every action, canary releases and phase rollouts, behavior and drift detection, automated rollback mechanisms, and continuous monitoring of agent decisions. You don't launch agents with a big bang release. You introduce them gradually. You observe them in controlled environments. You expand autonomy only when evidence supports it. And you monitor what actually matters: latency, error rates, policy violations, deviation from expected behavior, and SLA performance. If behavior degrades, the system constrains or rolls back automatically. That protects customers, it protects the business, and it protects trust. And there's another reality: models drift, data changes, and user behavior shifts. In an agent that was safe on day one, it can become unreliable by day 30. Without runtime feedback loops, you won't see that coming. Shift right closes a loop between design, deployment, and reality. Now here's the important part: the combined effect. These aren't three separate ideas, they form a control loop. Shift up, humans define intent and architecture. Shift left, constraints and validation are built in from day one. And shift right, live agents are observed, corrected, and constrained in production. Together they solve the productivity risk paradox. AI increases velocity, but unmanaged velocity increases exposure. The answer is not slowing down, it's redistributing control. Constrain earlier, operate higher, and observe continuously. That's how you accelerate safely. So what does this mean practically? Well, if you want faster time to value, you have to set autonomy boundaries at the start. Encode policy before you build agent logic, let Gen AI automate the implementation middle, deploy using trust tiers, not big bang releases, and invest in runtime observability from day one. If you skip any of those, well, you'll pay for it. You'll over-engineer, or you'll ship unsafe autonomy, or you'll stall in compliance and security reviews. Winning teams don't move faster by removing guardrails, they move faster by shifting guardrails left, lifting humans up the stack, and tracing every action in production. Agentic AI changes how software behaves, so we have to change how we deliver it. Shift left prevents avoidable failure. Shift up removes human bottlenecks. And shift right protects value in the wild. Think earlier, operate higher, observe continuously. That's how you accelerate agentic AI delivery without losing control. So if you're serious about getting agents into production, start with the operating model and not the use cases. Speak soon.